Hi there. Let's see how we gonna or how we can answer this question. It says study the four graphs below. Choose the graphs that describe each situation. Each graph may be used more than once or not at all. Okay, so you can read that yourself again and try to understand the question. I'm gonna move on to answering it. The 8.1, which is the first part, says let me actually move this up because you might not be able to see it. Okay, so this is the question. It says, study the four graphs below. Choose the graphs that describe each situation. Each graph may be used more than once or not at all. Okay, so now we've got this graph here. It says the forward and end reverse as equilibrium is approaching. The forward and reverse rates as equilibrium is approached. The forward and reverse rates as equilibrium is approached. I think that would be A, B, and D. Okay, so we're gonna write A, B, and D. The reason why is because they say the reverse and the forward. So this would be our forward graph. Wait, no, this would be our reverse graph, and this would be our forward graph. Here, this would be our forward graph and our reverse graph. Forward graph and our reverse graph. So you can see, as for C, there's no forward or reverse graph, it's just one line. So you're going to select A, B, and D for question 8.1. Let's look at the next one. It's 8.2. The reactant and the product concentration as equilibrium is approached. The reactant and product concentrations as equilibrium is approached. Let's see. I think looking at the concentration. Let me just erase this quickly. If we're looking at concentration, we have to think about how concentration remains constant and it is not equal. So over here it tells us that there's some sort of equality there. So that means it should be A and B because there's some consistency there. So we're going to put that down as A and B for question 8.2. Let's go on to question 8.3. The change in concentration for the reaction that runs to completion. Come on, this is obvious. It's obviously C, because remember it's the change in concentration for a reaction that runs to completion. It's actually obviously like it starts here from such a high point on Y and then decreases to 0, meaning it has run its course, so there's nothing left at the end of it, and the reaction that runs to completion. So that means our question for 8.3, that is C. Let me write that in green. C right over there. Okay, so that's how you answer this question. I hope I helped you in this activity. I'll have to see you in the next one.